Hi, for this new season, we are going to do a few episodes on SPM State Paper 2024. So by chapters, today we are going to start with heat chapter. So let's start. So guys, remember, you can download this material in the description below, load it up in your iPad, print it out, and you can write with me and we'll do this together. Now, the first question that we'll be looking at is actually a percobaan negeri Terengganu. So this is a very basic question just as a warm-up. Okay, so let's start. So name the heat release on H. So H is when the water actually turns into ice. So obviously, before we talk about heat, we always need to remember. So heat generally, we got Q equals to mc theta. We also got this thing called Q equals to ml. Now, so when do we use mc theta? When do we use ml? So first of all, you need to know that C actually stands for specific heat capacity. L actually stands for this thing known as specific latent heat. So when do we use specific heat capacity? When do we use latent heat? So this is usually when your object has a change in temperature. So this is when your object actually has a change in state. So you have to be able to recognize what is the changing thing in your object. So here there is a 0 degrees Celsius to 0 degrees Celsius. So there is no change in temperature. There is only a change in state. So oleh itu, this will definitely be what we call the latent heat. However, latent heat actually, right, got two types of latent heat. So what are the two types of latent heat? So latent heat, right, is applicable to when you go from solid to liquid, liquid to gas, gas to liquid, liquid to solid. So for liquid and solid punya change, so we will call this as the latent heat of fusion. And from liquid to gas, we will call that as the latent heat of vaporization. So this is the difference. So when we look at this one, because this is from liquid to solid, so we will say that this is the latent heat of fusion. Okay, Ken? All right. Solid to liquid. Okay, so now we want you to find what is the heat that needs to be released by the water at 25 degrees Celsius for it to become a temperature of -5. So they actually already give you these three stages. Now, so for me, I prefer to write down my own phase, whereby, okay, I know that I start at water 25 degrees Celsius. I want to get ice at -5 degrees Celsius. So let me write this down. So we start at water 25 degrees Celsius. My ending state is ice at -5 degrees Celsius. So what goes through your brain, right, is you need to imagine that this is the cooling curve in your chemistry. So whereby this thing needs to reach the freezing point to become water at 0 degrees Celsius, then only it will be able to undergo the melting, the freezing process to become ice at 0 degrees Celsius, then only it will become -5. So here to here, we have something called change in temperature. Here to here, we got something called change in state, and here to here, we also got this thing called change in temperature. Now, so based on this, we recognize by there is a temperature change. So this part is a temperature change, this part is a state change. Then on the last part here is a temperature change. So temperature will be Q equals to mc theta, state will be Q equals to ml, temperature will be Q equals to mc theta. So my object, how heavy? 0.8 kg. So remember, we need to use everything in terms of SI unit. So if they give you gram, you have to pandai change to kg as well. Okay, so here this is water. So we have to find what is the specific heat capacity of water. Do you need to memorize this? No need, because this will always be given in the question. So now, specific capacity 4200. What is my theta? So theta is my change in temperature from 25 to 0. Remember rule number 1. Theta will never be a negative value. So therefore, we will always take big minus the smaller one. So it's 25 minus 0. Can you straight write 25? Yes, but I prefer to write minus so that I remind myself that I always try to take a difference at that, okay? What about this ml? So 0.8. What is L? L stands for latent heat. So if this is from water to ice, from liquid to solid, the latent heat of fusion of ice is also given. So therefore, here we will take 3.34 times 10 to the power of 5 equal sign. Then after that, the next one will be from ice 0 degrees Celsius to ice at -5. So it's going to be M 0.8. Specific heat capacity of ice is a different one because specific capacity of water and specific capacity of ice is different. So they already give you is 2000. So here is 0 to -5 degrees Celsius. So you can just straight write 5 if you want to. So when you add these three values together, you should get 3.592 times 10 to the power of 5 joules. Okay, right, wrongly. 5 joules. So that will be the total heat energy. So this is actually a 3 marks question. So it's actually quite easy. Okay. Now, then they'll give you some, something like a structured essay question like that. So they'll ask you, okay, so this is a egg steamer pot. So whenever we think about all this, you want high or low specific heat capacity, you always need to think, okay, capacity is what? Capacity is how much heat you can keep, right? Okay. Now, so if you have high specific heat capacity, biasanya means that, okay, imagine if I say your stomach is high capacity, meaning to say it's easier for you to become full or harder for you to become full if your stomach is very big. So you need to eat a lot only can become full, right? So therefore it is harder to become full. So meaning to say that it's harder to become hot. So means it will heat up slower. Alright, so you will heat up slower. So if low specific heat capacity means your stomach very small, means that you eat little bit because capacity is the size, right? So if you eat little bit, you become full, right? So means that you will actually heat up faster. Okay, so we never say heat up easily, very difficult to heat up, so we don't use that kind of easily word anymore. Okay, now new era already, guys. Okay, so now for a pot base, should your pot base heat up faster? Should it be a heat conductor? So the answer obviously yes. So when we look at this one, we are looking at low specific heat capacity. Of course, in exam, you write full name lah. So low specific capacity, why? The reason is because it is a heat conductor. All right, it's a heat conductor. So therefore, lesser energy is needed to raise its temperature. So therefore, it heats up faster. All right. So sometimes you see my point, right? I will write longer because every time they want the same answer as the schema jawaban. So if I write more points, heat conductor, so means that it will heat up faster, means that it takes less energy to raise its temperature. So this way I can make sure that my answer will sure kena the schema jawaban. Okay. So then I will get marks, increase the chance of me getting marks. What about the material of the pot body? So here we got left with glass and aluminium. So if you look at the glass, the pot body, very seldom you see bottom is metal, then the side is glass one, right? Correct. So usually we will take aluminium. So in this case, this is aluminium. Now, if you study chemistry, so chemistry will teach you that aluminium, magnesium, they are usually low density, correct? So if they are low density, so ultimately they will be lighter and portable, more portable. But guys, don't straight away low density, then you write more portable lah or lighter. In between your low density and your lighter here, remember, density will always affect this thing called lower mass, so therefore it is lighter, so therefore it is more portable. Okay, so make sure you don't forget this lower mass thing. Okay, Ken. Do you have any other words to use? Can you say heat up faster? Because here already say heat up faster already, low specific capacity. So usually the body is, we want to make the pot lighter. Okay, so oleh itu, this is our pot R. So therefore, this is one question on our Terengganu punya heat question. Okay, so without further ado, let's look at the next one. Okay, the next question is going to be a heating curve. So this will be our Penang set 2. Okay, this question is quite special. Okay, so guys, what about meaning definition? Okay, for definition, right, guys, is it worth studying? In my opinion, I think you should memorize definition. However, remember, the best definition is always from your textbook. So if you need to refer any definition, always refer to your textbook. All right, I will be posting a lot of my definition that I extract from the textbook, and then I will put it into my Instagram, which is also physics by Jung. So you can drop me a follow, you can refer to all the definition that I share there, because every definition that I share on my Insta channel will be from the textbook. All right, so definitely it will be accepted. Okay, Ken? Now, so let's look at this one. State of matter P to Q and Q to R. So whenever we look at heating curve, what is the most important thing? You must always check what is the starting phase. Okay, because it can start from liquid, it can start from solid. So if I know that it starts from solid, means that this is a solid phase, this is going to be a liquid phase, this is going to be a solid and liquid phase. Okay, guys, don't write semi-solid. So here we will say P to Q is going to be solid and liquid. And if you ask me what is the Q to R state, so the Q to R state will be the liquid state. Okay, Ken? Alright, so it's two different states. solid liquid, solid and liquid, that's liquid. Okay, why the temperature is constant at PQ and the temperature is increasing in QR? This is interesting. Okay, so according to chemistry, so what do we always write? Why your temperature during heating is constant? So we will always say why? Because your heat absorbed is used to overcome the forces of attraction between the particles as, let's say, solid turns to liquid. Okay, can, all right. Now, and I want you all to always add this answer in as well. So, because you have to say why temperature is constant, so therefore the kinetic energy is constant. That's why your kinetic energy will cause your temperature to be constant. Okay, your temperature is constant. So here lah. Okay, kalau you ask me, so why from Q to R, the liquid state, my temperature actually will increase? So the answer is very simple. Because as the heat absorbed is used to increase the kinetic energy of particles. So when your kinetic energy increases, usually your temperature will be increasing. So it's very simple, punya. Okay, so you get 2 marks already. Now, then we go and see this calculate the energy absorbed. Now, this question, right, if you see most of the reference book, buku latihan, this question right now is slightly special. Why? Because most of the time, we will use PT equals to MC theta, PT equals to ML. You know, we can calculate power times time to find the energy needed or energy used. However, if you look at this whole entire question, there is no power given. There is no power in the question. They just give you time and then they give you all the unit, all this temperature. Then they want you to count. So that's why here you cannot use PT. So you're trying to find everything from P ke R, P to R. So how to do this? We also have to start with our just now punya phase up. Okay, so from solid to liquid here, from P to Q, this is actually a change in state. So kalau this is change in state, this will be Q equals to ML. Now, if you see the top part, okay, now the top part is actually Q to R. So Q to R is actually a change in temperature. So kalau change in temperature, this will be equals to Q equals to MC theta. So what are we going to do? Use all the values that is given lah. So the specific heat capacity of the substance, okay, we do the right hand side one first. So mass of the thing, how heavy? 0.7 kg. So 0.7 kg. 1970 specific heat capacity, and the change in temperature is going to be 45 minus 30. Why? Because it went from 30 all the way to 45, right? So what is my Q equals to MC theta here? Okay, so I've calculated this to be equivalent to 20685 joules. All right, what about my change in state? So my Q will be equals to my mass 0.7 kg, and then the latent heat of fusion here, also given already, guys. The latent heat of fusion is 2.67 times 10 to the power of 5. So 2.67 times 10 to the power of 5. So I'll be able to calculate out my total energy that we use here to be 186,900 joules. Okay. So if you want to find what is the total energy absorbed from P to R, so what we need to do is we have to take the 186,900 and these two 20685. What we're going to do right now here is we will actually try to add them up together. So when I add them up together, I'll get 207,585 joules. Okay, so you can try to press calculator. Tell me if you get it right or wrong. Okay, sometimes I might be wrong with my calculator. Okay, now so far very smoothly already gotten all the marks in this page. There is already 9 marks. Yep, 1, 2, 2, 4, 9 marks. And then sometimes they will say, what is the assumption made in 9B1 to get our 10th mark in our essay question? So what's the assumption here? So when we do heat, most of the time, our assumption is all the same one. The assumption is always what? The assumption is always there is no heat loss. Sometimes it will be no heat absorbed from or to the surroundings, from the surroundings, or you could be no heat lost to the surroundings. So why loss or absorb? Sometimes it will depend on your question whether that one will absorb heat or release heat. So this one I will feel like, because this is a heating curve, right? So we are worried that it will lose heat. So I will say this is no heat is lost to the surroundings. Okay, but some other melting question we will say no heat absorbed from the surroundings. Okay, Ken, all right. Okay, so now this is where things get a bit more interesting because we're going to talk about our radiator. Okay, radiator is recently considered one of a favorite question, hot topic. You can say so. What happens here is that usually what we do, we will pump water into the radiator. So the radiator machine dekat sini has the engine. So what will happen is that the engine will actually release heat. So the point of the liquid here is to absorb the heat so that when it goes out, this thing will become hot water already. So maksud that is cold water. So this hot water will pass through something what we call the cooling fin. So the cooling fin are strips of metal. So whereby if you want to see how a cooling fin looks like, you call papa, right, or mommy, go and book up the aircon, and you will see that there will be two filter, aircon filter that you need to wash. Now, if you see behind the aircon filter, there will be blades, like one piece of blade punya, like metal sheets like that one. So what happens is that when your car moves or when the air flow across the aircon, the air will actually go across the cooling fin and then it will release the heat. So it will carry the heat away. So therefore your hot water will then be able to release the heat and slowly become back cool water. Okay, so the normal water lah. So after that it will go through this process again. So your cooling fin, you need to have more. So the whole purpose of this is to actually increase the surface area so that more heat can be lost, okay, to the surroundings. Okay, so this is for car radiator. Now, however, the most difficult part about car radiator, guys, you have to listen this, okay, is the cooling agent in the car radiator. Okay, so there are two main characteristics of a cooling agent in a car radiator. If possible, take a pencil, write this down somewhere. Okay, now, so first of all, the cooling agent in a car radiator must have high specific heat capacity. Okay, why high specific capacity? So just now we say already, if something has high capacity, means that it will not absorb heat easily, right? Correct, easily, right? But we will say that we don't want to write easily. Okay, see, watch how I write this. I will say that a high specific capacity means that it can absorb more heat energy with small increase in temperature. Okay, now why small increase in temperature? Now, you pernah guna any cooling agent or not? Now, one of the best cooling agent I can think of that you probably used before is actually, you guys know what is the cool fever or not? Do you have any idea what is the cool fever? So this cool fever is actually the blue color gel that you put on your head. So when you have fever, right, then it will release the heat, then the cool fever absorb the heat. Okay. However, guys, the cool fever, as it absorbs it, right, will the cool fever become hot? No, right? It will try to remain as cold as possible. So it has high specific capacity. It will be able to absorb more heat energy. So the cool fever can absorb more heat energy, but the increase in temperature is very small. So therefore, the thing will remain cold for a longer period of time. Okay, can Okay, then selain daripada higher specific capacity, it must also have high boiling point. Okay, because we don't want the water in your car engine to boil. If the water in your car engine boil already, right, means the water will evaporate, means the water will hilang. So when the water hilang already, your engine inside got no water, then your engine will overheat, then your engine will rosak. Okay, so how can we write this? We will say that it can operate at high temperature without evaporating. So meaning to say that if it has high boiling point, my engine can reach high temperature and then it will not evaporate. Okay, or you can say that it will evaporate at a higher temperature. It will only evaporate at a higher temperature. So meaning to say it will exist as a liquid state. Okay, so this is also one of the answers that you can write. Okay, so don't get confused because this one is going to be related to our next question. Okay, I'm just gonna jump to our pahang because then I want to show you this is a fridge. Okay, for fridge here, they will talk about, you have to explain how the cooling system in a refrigerator works. Now, the good thing about today is I can teach you refrigerator and I can also teach you air conditioner, which is your aircon, which pretty much is exactly the same, only fridge smaller, aircon bigger. Okay, all right. Now, how does a fridge actually works? So let's just start from here. So biasanya, there is a cooling agent. So we are also talking about the cooling agent. So now it is in a liquid form. Biasanya, it is a liquid form. So this liquid cooling agent will pass through this whatever butterfly looking thing. Now the proper name of this is actually known as an expansion valve. So we want the liquid to expand, okay? So why we want the liquid to expand? Okay, just imagine I spray the liquid into small droplets. So when I spray the liquid into small droplets, you will realize that then it will start to form small droplets of liquid. So when it muscle, the liquid will slowly become gas. Why? Because smaller droplet easy to evaporate. So why do I want it to evaporate? Okay, because during this evaporation process, it will absorb heat. What heat will be absorbed? Very simple, guys. It will absorb this thing called the latent heat of vaporization. So as the liquid slowly evaporate, so it will try to absorb heat all as it goes. So absorb. Okay, then after that, you will realize that so this now exists as a gas, and don't forget your gas starts to heat up already. Why? Because it keeps on absorbing heat from the fridge. So now this gas sudah panas like that. So it goes all the way down, it goes into this compressor. So what happens in the compressor is your compressor will actually compress the gas slowly to encourage it to gradually become liquid. Okay, so it haven't completely become liquid because it compressed already. Then but tambah dengan your condenser coil. Okay, what is condensation? Condensation means that you are going to take a gas, and you're going to change it to liquid. But when there's condensation, this will actually release heat, betul kan? So when it releases heat, that's why you will see that the back of your fridge, the belakang of your peti sejuk, is going to be very, very, very hot, guys. Why? Because it constantly releases heat at the back. So then your hot gas baru can slowly become back the cold liquid. All right, so this is the whole process. So what do we usually write? How do we usually say if this is a 3 marks? Okay, so we can start with the point number 1. We can say your cooling agent. Did they use the word? Okay, see, they were cooling. Sometimes they say cooling liquid, sometimes they call cooling agent, so it's up to you. So the cooling agent will evaporate as it travels in the refrigerator. Okay, so I talk about evaporation. So we can say as it evaporates, it absorbs, okay, the latent heat of vaporization from the inside of the refrigerator. Okay, why? Because this thing happens inside. So the specific latent heat of vaporization. Exam tolong lah, right? Full name lah. Okay, so that's your latent heat of vaporization. Now, which then this leads us to point number 3. Okay, so what's my point number 3 here? So after it becomes gas already, right? So you can say it will go from liquid to form gas, from liquid to gas. Okay, so the gas will go through the compressor, all right, go through the compressor, okay, and condenser coil. So it goes through the compressor. It also pada masa yang sama goes through this condenser coil to release heat to form back cooling agent in liquid form. Okay, so this is 3 marks. Okay, of course you want to break this into more parts. You can also say like, okay, what happens in the compressor? The compressor will use high pressure to compress the gas back to the liquid form. So in condenser coil, you can also say condensation will actually release back the latent heat of vaporization. Okay, so yeah, usually guys, okay, this is my own personal advice lah. Okay, when you answer all these 3 marks question or 4 marks question, right? You don't straight away write into your full scat paper. Okay, if you have time, you can write out like this first. So like you got a rangka karangan, then later on you can add more points. So now I will feel like I want to add this condensation, release, latent heat, or vaporization here. So I want to masukkan so that my answer will sound more complete. Okay, can? Alright. By the way, this kind of 3 marks or 4 marks question, right? You are allowed to write more points, meaning to say you want to write 4 or 5 points pun boleh, but don't write 20 points lah. Okay, can? Alright. So 3 marks you write 4 points, 4 marks you write 5 points. You can increase your chance of kena the jawapan that you want. Okay, can? Alright. Okay, so I already explained to you how this whole thing works. Okay, so what is the fun part here? Okay, so they might ask you about the cooling agent in your fridge. Okay, when we talk about the cooling agent in the fridge, okay, let me write somewhere here. Okay, this one sikit susah sikit. Okay, why? Because do you want it to evaporate? Okay, so first we talk about this first. So you have to say that you want higher latent heat of vaporization. Okay, why do you want higher latent heat of vaporization? Very simple, guys, very simple. Okay, because you want it to evaporate. So during this evaporation, you want your cooling liquid to absorb more heat or to absorb less heat. So you want a high latent heat of vaporization so that we can say during the evaporation process, more heat can be absorbed from the fridge. Okay, so more heat can be absorbed, so therefore, or you can say more heat can be removed from the fridge. So I want it to be able to bring more heat away, so that the more heat it absorbs, the more cold my fridge will become. Okay, can? Alright. Okay, then, okay, this is where it gets interesting already. Okay, so this is high latent heat. Okay, now, this one is you need to say that it has to have low boiling point. Okay, tengok. For car radiator, we are comparing high boiling point, high specific heat capacity, not latent heat. For fridge, it's going to be latent heat, not heat capacity, and boiling point terbalik juga. Okay, so these two things are the point are totally different one, guys. Okay, so why I want low boiling point? Okay, let me give you an example. Now, you pernah take sanitizer and pour on your hand or not? Now, if you try to pour sanitizer on your hand before, you will realize that as the sanitizer touch your hand, you feel that your hand like cold one, right? Quite a bit cold one, right? So why your hand will feel cold is because as the sanitizer touch your hand, the sanitizer will evaporate. The alcohol content in the sanitizer will evaporate. So during this evaporation, it will absorb heat from your hand. So therefore, your hand will feel the cold sensation. So therefore, heat is being removed. Okay, so a low boiling point, meaning to say that what I want to achieve here is I want the cooling agent to be able to evaporate at a low temperature to absorb heat from the fridge. Okay, so kalau tak silap saya lah, an average boiling point of a coolant nowadays is about negative 30 degrees Celsius. So meaning to say at negative 30 degrees Celsius, it will evaporate, so it will absorb heat. So I want low boiling point so that it is able to evaporate at low temperature to absorb heat from the inside of the fridge. If you want to say, also can say from the inside of the fridge. So please do take note that the cooling agent of car radiator and the cooling agent of refrigerator is none of the point is the same one. Okay, walaupun they both sound like cooling agent. Okay, Ken? Alright. Okay, so now let's have a look. Okay, by the way, the essay answers, right, are all located at the back of these notes already. So feel free to go and write your essay on your own. This is actually quite easy because the answer is just C only. Why? Because your cooling fin has to be a heat conductor so that it will be able to release heat faster. Alright. Now, however, the next question here, this one may be slightly more interesting. Okay, for this Penang Pahang punya question, you will realize that this is on a electric steamer without a lid. Okay, so now if you have to choose a lid to cover your electric steamer, so your specific capacity of lid is what? Do you want a high specific heat or low specific capacity? So what's the use of a lid? So the purpose of a lid is so that you tutup this thing, you'll be able to okay, don't say prevent, guys, to reduce the heat loss. So I want my lid to have high specific heat capacity so that it is a heat insulator so that it can reduce heat loss to surroundings, okay? So that I can reduce the heat loss to surroundings. And why would I want to reduce the heat loss to surroundings is because I want the heat to be trapped inside the egg steamer. Oh, sorry, the electric steamer, okay? So reduce heat loss to surroundings. Can? Okay. So of course, now I'm left with these two lah. Okay. Do you want more water reservoir? Okay. Because this is a steamer. So a steamer, right, you have to tambah water on, right? Correct. Because you're gonna heat the water. The water will evaporate, and then the water will condense on the food to cook the food. So the process that cooks the food is actually condensation, because condensation release heat lah. So you need more water, obviously. So now, how do we determine the last one? Okay, so the rack, obviously, I want more racks. Okay, more number of racks. Why? Because whenever we pick this kind of question, we want to see what you want to cook large quantities of food more quickly, efficiently, and safely. So oleh itu, we will pick 3 so that I can stack more food. More food can be cooked at the same time. So my answer here is J. Okay, so why nichrome? Okay, nichrome is actually related to our Form 5 Chapter 3. So this one maybe we will say in another video, but it has something to do with high resistance so that it will produce more heat in a short period of time. Okay, Ken, all right. So therefore, this is my electric steamer question, which is not very complicated. So you will see that they also give you all the latent heat and heat capacity calculation. So guys, state papers, suka tanya this, SPM also like to ask. From you see, it will be from water to steam. So what you're gonna do right now is, okay, water, 30 degrees Celsius. Okay, so first your water must heat up to become 100 degrees Celsius. Then only it will become steam at 100 degrees Celsius. So MC theta and then ML. Alright, that's why you have to know when to use MC theta, when to use ML. Okay, now last part for today. Okay, if you see this question is actually our Selangor punya question, set 1. Okay, whereby they'll ask you certain questions, quite K-but one. So when they a lot of students, when they do this essay question, right, they didn't do very well because 2 factors. Number 1, they never see this question before, obviously, so they're very scared. Number 2, they never read, like, what's the point of this? So the grill can be held securely, and it is portable, able to grill large amount of food quickly, and is to without the disturbance of the wind from the shore. Okay, so what is the answer that we need to write here that you can prevent the disturbances of wind from the shore? So obviously one of the answer is I will add a lid on top of it lah. So if I put a lid, imagine wow, wind come already, right? I use this thing, wow, straight away cover. So the wind will just block completely. Alright, so that's one of the answer. So number 2, I can also say that I have more tier. Okay, like I can increase, put more larger grill net so that more food can be cooked faster. Number 3, I can even say that the grill net must have low specific heat capacity so that it is a heat conductor. It will be able to cook in a short period of time and everything. Okay, and then you see, guys, they say one more portable. Can I say I add wheels? Can or not? Portable wheels can? Of course can guys. You know, like your but this one you need to say the net is low specific heat capacity. Okay, the wheel so that you'll be able to push this thing everywhere. And then last but not least, what else can you say? Here they got say the grill can be held securely, portable grill. Yeah, okay, guys, if you all see, right, those people who sell satay, right, they'll fan the satay, right? Or sometimes they'll put a fan near the satay, right? Okay, why do they want to fan the food? Okay, I know, right, like got some people, some students, right, they go barbecue, okay, and then manatao they couldn't start the fire, okay? So what is the problem? Okay, I suspect they never try to fan the arang, they never fan the charcoal because the charcoal needs oxygen to burn, right? Correct. So the fan will be able to supply more oxygen to support the burning of the charcoal. So this is also an acceptable answer. All right, Ken. Okay, to support more oxygen to burn the charcoal. What else can you say? For example, you can also say that maybe the handle needs to be insulator, dan sebagainya lah. So it's actually creativity punya question. Okay, Ken. All right. Yeah. So This question is not difficult. The answers are provided. You can try them yourself. Now, another one more last question that I just want to, give you all a point is that remember, gas law is very important. But sometimes when gas law come out, right, very simple one. Okay, why? Because they call you to do a comparison. Okay, no matter what you see, you always try to check three things. For gas law, it's always pressure, volume, temperature, right? Okay. So if I look at this question, I will look at the thermometer. So my thermometer is constant. So therefore, this is going to be volume. Okay, I can see that the volume here is different from the volume over here. And I can see the pressure reading here is different. So this is going to be a pressure and volume air. So walaupun they say in the question, but sometimes they don't mention it in the question, which also means that you have to find yourself, okay? And then definitely they will call you to do a bunch of comparison. So compare the volume, compare the pressure, compare the and then state. So this is going to be our Boyle's law, okay? So yeah, so therefore this is on our MRSM question. Now for this episode, I will sampai sini sahaja because we discussed a few important essay questions already. We also discussed what are the important things. If you have any questions or if you want to ask anything related to HIT punya essay, feel free to drop me a comment below. So thank you everyone. I'll see you guys in the next episode.